So hi everyone. So today we'll go through a final presentation and we're team 8. So our team member has me, Eileen Gu, Shubham, and Zhixian. So first we'll go through the system architecture overview with you guys. So looking at this picture, we have 5 major regions in our system architecture. So the first one is our Kafka string and the API. So from there, we can do ETL feature collections and push those data to our storage layer below. So the storage layer we use is in blue color. And we use MongoDB as our major source to pull and push the data for model training and logging purposes. Then we come to the load balancer, which will route all the requests from our instructions VM to the A/B testing ML services. And the final part is the monitoring. So it basically pull the data, for example, like the request data code, request latency, and model performance matrix from the Kafka string and the load balancer. And next, we'll go through the key design decisions and also the reflections. First, we will talk about the data storage layer we use in our projects. So we use MongoDB as our major source for the data storage layer. So compared to the relational database MySQL, so the MongoDB supports a much more flexible and schemaless document structures. So it better fits the flexible and dynamic nature of the data we handle. And compared to the traditional CSV files local storage, we avoid the traditional bottleneck that CSV files can have. So it's like the memory overhead that CSV files have to push to our memory or our disk. Also, using CSV files would become much more problematic as the system scales in production. And next, we'll come to the model updates decision.
Okay, so for the model update, the design decision we made is that each model server is configured to periodically train it, retrigger its own retraining process, and it's based on a fixed time interval. And also the data is pulled by the server from our MongoDB database, and also so the model is trained by using some fresh data. And once the retraining is complete, the updated model replaces the previous one in the memory, and the server begins serving the predictions using the new version without the downtime. Okay. So the drawbacks in our current auto update decision is that the retraining is currently done independently in each model server. So when we have like a deployment, during the deployment time, we may have like several model servers, and each one does not initiate a server at the same time. So it may lead to some inconsistencies in inefficient resource use. And if I can do it another time, I will use Jenkins for centralized retraining and deployment. And also for the teamwork, I will have do some early planning for production scale operations. So yeah.
Now the third design decision is the online evaluation metrics. We couldn't only rely on RMSE. We have to define some product-oriented metrics like average watch time, which is the total watch time divided by the number of users. And we have to find the conversion rate, like number of users who watched it and divided by the number of users who actually were recommended. We use the user behavior logging, decided to log timestamp interaction using MongoDB. We used a scheduler setup for a custom job. Now, on the reflection, we moved from thinking like a data scientist to a product engineer because we thought in a real-time recommendation coming back from the user. The challenge was how to use the converted or the conversion rate of the user, which is partially watching it or watching it fully. So the lesson learned it, we have to make actionable, interpretable goals. Now the A/B testing infrastructure, SVD versus KNN. The initial plan was to use the growth book tool for splitting the data and visualization, but we had to change our plan and we have to use a custom round robin assignment of the users to SVD and KNN because of the integration challenges and the lack of flexibility in the backend telemetry matching. The telemetry tagging, each user request was tagged to a specific model type, and the logs were later stored in MongoDB. The reflection part on the A/B testing was an interesting insight. The custom logic which we used rather than using a growth book tool was that it gave us a better control and made us the debugging easier. The issue was that the data volume slowed down the log entries, so we have to limit the testing to 3,000 users per performance. The bug was that some logs were not tagged correctly due to race conditions. That taught me the value of idempotent logging.
Okay, so final part is we'll go through an overview of our teamwork heuristics. So first we'll go through a members overview. So currently we have 3 members in our team, Zhixian, me, Ailing Gu, and Shupan. So our teamwork heuristics is that we kind of divide our team into software and machine learning subteams to better match every member's expertise. So within the machine learning team is Shubham and Zhixian in charge. They're mostly responsible for machine learning modeling, training with data processing, and also model performance analysis, online offline model evaluation, and A/B testing pipeline. So for the software team side, so it's me, Aileen Gu, mostly in charge. I'm mostly responsible for Kafka API ETL feature collections and processing. Also, I'm in charge of system infrastructure design setup, monitoring infrastructure setup, CI pipeline setup, and finally, even though it's not yet finished, I'm responsible for containerization and Minikube deployment. Now we'll go through some teamwork reflections.
Yeah, so the first reflection I have is so the problem I encountered was during the teamwork. First, the collaboratively coding in the same components is somewhat time consuming. So basically if we are coding about a similar part, we have to integrate the code. So yeah, because the different coding habits make integration harder. And then so the solutions will be set shared coding guidelines early and then schedule regular coding reviews and inter-team check-ins. And also we can leave more testing and integration time during each milestone. So yeah, that's my part.
So the second reflection was the distribution of workload and responsibility within the team and the split between the ML software where each team needed to get to know that what other team is doing. So we can do it by using cross-functional checkpoints and technical sessions weekly.
Thank you. That's our presentation.
Thank you.